Alright, so we talk about chapter 24, linked list. Okay, we're going to continue on what we have left out, right?
This is true.
So last time we created a node, right? We created a linked list class that pretty much use the node when we add. And we test that. Test to add 3 strings, and we create the 2 string depending on the linked list iterator. So we have tests and we see we are able to add 3 strings into the list. Okay, so next what we're going to do, we're going to remove. So we could go back to look at the image that we created last time. So this is our linked list with 3 elements, right? So let's take a look at the elements that we add. Again, we have David, Mary, and John, right? So now the question is, if I remove, it's going to remove either David, which is the head, or Mary, which is between, and John, which is the tail.
You can change things a few different ways with that. Doesn't it just change the pointer to point from A to C instead of A to B? I know, like, depending on how you code it, you either change it so it changes the pointer from, instead of going from A to B to C, it just goes from straight A to C, you skip B, but B will still actually be in the memory. The other way is just move everything up the list. Or there's a few other things you can do, right?
So the question pretty much just like you mentioned how we're going to remove this, right? It's just depending on the location of the object, right? So that means you have to check if it's the head. If it's the head, then you technically want to move the head, right? If it's the head, then you technically want to move the head from this location to this, correct? And then we just don't have to worry about this.
I get how you do that logically. Logically, you're just changing the head from A to B.
Yeah, because this is going to be cleaned up by GRE, which is garbage collection, because you have the new list. So let's talk about how to remove the head. First, remove pretty much is going to take the object that you want to remove, right? So I probably has to review. How come they don't have E here? We have remove. Oh, I was looking at the iterator, so I have to look at remove here. So first we have to check if it's the head. How do you know if it's the head? So even before we remove, we have to check if it contains.
We don't know.
Right, if it's not containing, then we don't need to move, correct? If contains, so we should have the method name contains, right? If it's contains, so that means if it contains E, it's going to return true, then we remove, right? Or if it's not contains, what do we do? We should notify with the exception, right? So we should return new exception. What's the name of this exception? Okay, no pointer exception, like we don't have the object.
You need to write object on it
try and catch it, you already know it's gonna be there.
Do we return or we actually?
Shouldn't we throw?
Yes, we should throw.
Throw the exception. Can't we lightly toss exceptions? Should we really be throwing them?
So if not contained, we throw the null pointer exception. So technically, whenever we cache that, it will never reach this line, right? So this line we can start to implement, right? So first we want to implement what? If head, right? If we try to remove the head, right? So how do you know if the head? So we actually,
Dot next is equal to null. Because it
doesn't have to be, right? Dot next never know in this case.
no, if it's
Head was David. Dot next is Mary. And it's not no.
what I'm
Look,
saying. Oh, dot previous. There's no
dot previous. We never talk about previous.
No, we don't have previous.
We don't have previous. How do you know we remove the head?
Can we use size? If count equals 0?
How do you know it's head? You said size? What?
Yeah,
You have this like in
Its head is like
If size what? Equals to,
size equals 1, I guess.
but size not equals 1. It's going to be 3, right? Before we remove.
Count. Just count. Show which one you're on.
We try to remove head, right?
um
Like I try to remove David.
the index, so in the headers index is 0, so if it's like a return 0.
Index. So what's the index of David?
when the
If
index.
it's head, then it's 0.
How do you know 0?
How we have implemented index yet?
So how do we know 0?
Can we go back for a second?
So let's look at contains first. Let's implement contains then. We're not done with contains yet, right? How do we implement contains? So we pass in David. I want to know if David on the list. So how you implement contains?
So
Hmm?
size equals 0, we return false.
Do we need to implement comparator?
So he said if size equal to 0 returns false. What do you mean? You want to check the size?
If,
Right.
yeah,
First, if it's empty, then it never contains, right?
If it contains
yeah,
something.
if the link is empty,
If
if it's empty, we return false.
is empty,
Yeah. Return false.
then returns false. Okay. So let's say we just start with boolean contain, and we set it to false.
So return contain.
While dot next is equal to null, not null.
At the end, we're gonna return contain, right? Okay. And okay, now if it's empty, we said false. How that mean it's going to do this line when it's not empty. Okay.
So while dot next is not null, then go to the
Wow.
We have an iterator already, right?
Yeah.
We implemented the iterator.
Yeah, we have iterator. We have the iterator at the bottom.
So in order to check if it contains, we should implement the equals method to check if one object equals to another object.
Okay,
Yeah.
but we don't have to implement because we use string. String has equal already.
Okay, okay.
Correct? We use string.
We'll just use
String has equals already.
Mhm.
If you have your like user class, like your assignment project, then yes, user has to implement equals, right? All the object must implement equals. But now we want to focus on how to implement contains by assuming that the one who uses contains must implement.
Equals to.
Which, if you want to do that, you can just say e extends comparable, because comparable has compare to. E extends comparable. Let me put on extends comparable right here, right? So the reason we put this to make sure that the object E must has the compare to method. Otherwise, they cannot use this linked list. That makes sense? Okay, to answer to the ask question. Alright, so we take care now, we're done with that part, then we don't have to worry about, right? The object must implement compare to. We can just compare to, right? Return zeros, right? How about equals? Equals, is it part of any interface? Yeah, what's the equals method belongs to? What class or interface?
Object.
Always object, right? Object Java doc. So then equals, right? Okay. Then technically, if you want to use equals, you don't have to do extends comparable. But if you want it to be order list, then you have to do extends comparable. That makes sense? But in this case, if you just want to use equals, you don't have to. Alright, so if you want to use equals, then we don't have to do that. Alright, come back to how to implement contains. So none of you really know how to do this, right?
So are we going to use the iterator to do this, or just a for loop?
Okay, we can use whatever we need. Okay, let's see if we try to use iterator, what happens. Okay. So we said we can create an iterator object, right? In that case, right? If we want to use iterator, so okay, we're gonna create an iterator object, which is what?
Iterator, and then iterator is equal to the iterator method.
Equals to the iterator.
No, we should be able to just do iterator, because I think we have a method in this class that returns the iterator.
Can you repeat what you tried to do again?
We should be able to just do iterator, like the method.
Oh.
Class.
Like what I have here, right?
Yeah.
Remove the E.
Okay. Iterator. So now we get a current, which is in the beginning, right? And we try to find what? So then we know if it's a hit from there, right? The question again is, I think it seemed like the same question, like hate, right? So if what hate dot get elements dot equals to E, right? So, but this is for when you remove, right? So, but we want to do contains. So contains mean what? If head dot get elements dot equals to E, then the contain is true, right? So I mean this is taking care of the first one, right? And then
While iterator dot has next equal to
well has next if
next that element is equal to
next, I think it's iterator at next, right? Dot get dot next dot what? Dot next pretty much just return elements already. Dot equals, right? E, then it returns contains true, right? Contain equals to true, and then we technically can just break out the root, right? We found it, correct? We don't need to spend time to iterate it further. So technically it's going to keep iterating. Now if it's never found, then returns contain, which is false, right? I think it's pretty much look like that, right? We can test the contains. So let's test the contain then. Last time it didn't show either, huh? Okay, let's write in at test, and then we want to do public void contain, right? It's contained with S or without? Contains. Though exception. So we already have the list. So if we want to add something on the list, we have to add here, right? That means we need to call add here, right? Now we're going to test contains, right? So a list dot contains, and you could do the assert, right? Assert dot assert equals, and this is pretty much just the message, right? Expected true, and
shouldn't true not be in quotations since it's being returned as a boolean?
the first one is the message, right?
Oh, the message. Oh.
Yeah. And this is true, and then this is the result, right? So we can do with 3 of this for Mary and John. And we could assert, let's test something that's not true too, right? Like Daniel, false. So message premises we expect false, right? So let's test our contains to see if it works. Failed. Oh, because I happen to put the spaces. Okay. So it's not exact match, right? Greens. Okay. So we pass the test. So our contents looks good. That's what we should do, right? Whenever we implement, we test it first. Then now we can make sure that this one works, right? All right, we come back to remove. So we talk about if head already. How do you know if head, right? How much that? What if what? Head dot get element equals to e. Then that's the head. If it's contained and if it's the head, what do? According to the image, we just move the head to get next, right? Then we said head equals to head dot get next. So we done removing the head. And this one want to make sure you return true or false. So we gonna make a boolean, right? Say success or something like that. Like make it to false. Should we return here or just throw exception? So it depends, right? If we, it depends on the application. If you just want to notify, just do no party exception, right? Maybe we just want return fail, like success equal to false, just return success. So now this one we just return success, the status, right? And we can say equals to true because we just removed, right? All right, so what else? Let's look at image again. So if it happens to be Mary that you want to remove, in this case we have to change this, right? How do we change this? This guy has to point directly to this guy, correct? Like technically I need something like this, and then I need this to point directly to this guy, right? Like that, right? Correct. And then this guy is going to be garbage collection. Sure, he's going to clean it up. And this is the reason why Java is memory expensive. Always relying on garbage collection, right? Use a lot of memory. So now how do we do that? How do we know that we remove something in between? We remove something in between head and tail.
Get the middle index.
So David
We don't have
X
index, right?
is Mary. And
But again, it could be 4 elements. David could have Tom and Mary.
so you have to find the element before Mary. And then that element has to point to the element that's after Mary.
But after Mary could be Bob, and then John.
So which element are we trying to get rid of?
Mary.
Correct?
So you have to create a tab, maybe?
Can you say find Mary and then go to the node before?
And why you want to go to node before? That's my point.
So you can
Point to the one after Mary.
Right?
Yeah.
Because we need to set the one before, which is we call, what do we call it? Normally we already have it.
Couldn't we just check
But yeah, we can say this tail or not. If it's tail, then if it's not tail, then it's middle.
couldn't we just check
Really?
if the head
No. I mean, if it's not tail,
Hmm?
then
If it's standing by
Can we
this,
check if the head's next element is equal to E? Because we're passing an E. Or, oh, never mind.
Remember, this could be 10 elements between it.
Right,
And we want to get the middle of that.
right.
We cannot rely on head and tail.
Yeah. So we're not using head, we're just going through the iterator. And whatever it's on, the next one, if it is Mary, we have it point it to Mary's next one.
Mm-hmm. We have to do something like that. That's right.
How do we know that the Mary we
Yes.
have
I've been saying this all the time.
Hmm?
What happens
We
when
have to have one
multiple
more pointer.
the same type?
That's called previous.
Okay.
Right. So this guys. So we need to have a new pointer that's set and call it what? Previous, right? Right. All right. So we have to create a new pointer. So we have head, tail, and we have to have. Now, if you want to share, you just create at this level. But you feel like, okay, I only want to use inside and no longer need it. Then you just make it like local variables, right? Okay. For the remove. So if you create as the global, then you have to pretty much just when you instantiate it, you have to use it like initialize in the constructor node. We not really use it in the add, right? Head equals temp, tails equals temps. Do we need to use previous in the add? Good new node.
But does it,
Why use
Is it gonna be
previous if
helpful?
you can say if like whatever element dot has next equals Mary? Just do it that way instead. Right?
then dot element dot next. Can you do dot next? No.
Yeah.
Okay, he said
Can.
Yeah.
since we have next,
Get next.
we can check.
Get next dot next. I think. Wait, would it be get next or get dot next?
I think it's
If the next equals to Mary, meaning that we know the current, right?
yeah.
Then we can set the current to point to the next of Mary, right?
Right.
Yeah, we could do that. Now, how do we get a current?
With the iterator.
Would the iterator return the current?
No, it's current dot get next.
It say has next return. What has next again? Current dot gets next not equals to no. Oh, it's just true or false. Okay. So if the iterator can, if we make it to return current, then we can do that, right?
Right.
So pretty much just get current, right? If we add the getters, right? Public and node e get current. Like make a getter, right? Return okay, let's try that. So you want to use that. You said we don't need this, right? Let's comment now in case we want to come back. So we come back to remove. Alright, so how do we want to start out? We have to create iterator, right? Iterator. And this is the generates, huh? We should actually do the parameterize it, right? Okay, for now that's fine. Iterator equals to iterator. So what do? We get iterator object. And now we want to find something in between. So if we remove something in between head and tail, how do you know that it's between? You probably wanted loop again, right? Because contains is only return true or false, right? While what? Iterator dot has next, while has next, while, and then we look at if again. Iterator dot next, right? Equals to.
That was. Oh yeah. Goes to E.
We want to do next, right? Then we know the next one equals to E, right? Then we can say iterator dot get okay, because this is linked list iterator. That's why this belongs to this class, right? It will not give you this method, right? Because iterator only have these three methods. So I have to say linked list iterator. Linked list iterator equals to so this will return what you say, iterator. Where's the method iterator? It's happened to return iterator. That's why we don't have an access to that. This is a polymorphism concept, right? Unless you make it to return linked list iterator, or you create new linked list iterator here. Are you with me so far? Yeah. Like iterator itself only have 3 methods. You cannot access to that. But linked list iterator has more than 3 because it's a sub. Like this is a parent, right?
Oh yeah.
Parent cannot have more than children. Children can have whatever parent has, which is so lucky. Right? But parents cannot use the children things. Look like I cannot, like Israel cannot use get current. That's what it means, right? Then if I want to use that, okay, one way I need to make this as the new, right? Then I can have an access to it. Dot get current. So funny, right? It's also true, right? Your dad cannot use your shoes. You'll be complaining, but right? Is that true? Can your dad wear your shirts? No. But you could wear your dad's shirt, right? Alright, so that's what it is, polymorphism here. So iterator.getCurrent
Set pointer.
dot, so we get a current dot set next to iterator dot get current dot get next. Correct? Okay, let's review one more time.
Right.
Look at image and review this statement. All right. Technically we call previous here, right? Which is actually is a current, right? The same thing, right? We agree first. This is a current now that we use, correct? Then let me just change it to current then. Let me want to get confused. Alright, so this is a current. Now compared to this code, while we keep moving. Like now I'm at David. Okay. I try to remove Mary. I said dot next to David happen to equals the object that I try to remove, which is Mary. Okay, but my current's still here, right? Still at David. So what do? Let's make sure that my pointer is still at David. My next actually, when I call next right here, it actually moved my current right away though. Guys see that? It's actually not like that image. It moved my current. Because we move the current to get the element of it. Next is the one who actually where execute that line, it's actually moved that already. Make sense? When I do dot next here, so it's actually the image look like this now, right? Dot equals e, okay, which is fine. It's true, right? But if it's move it, then we're gonna be in trouble. We cannot refer to the previous, right?
Right.
But what we could do also, we could create a temp. Or it's called previous right here too. What we could do is before it move, like I said, we could make it global or local. If you want to move it global, we put this guy back, right? And we come back here, remove, we just say, before we move it, we just call previous equals to dot get current, right? Correct. And now we just go to previous dot set next. All right, let's review. Since current is pointing here, so that's why I call iterator dot, I should do dot get next then, right? But iterator itself is referred to this object. I have to get the current first to get its node, because in order to get the return a node, then I have an access to the pointer of get next, right? So that's why I have to put get current, because get current return is node, right? Then the node itself can get it next, which I'll set the previous to point to next. Right now, this guy is actually change the name back to previous here after I get a current assigned to it, right? Like if we put it back, it's gonna be like that. And then we technically have another pointer point to this called current too. Pretty much we have a lot of pointers going on. We all agree with this? Alright. So now
Do you have an issue when we hit tail? Because
that's why we have to check if it's going to have an issue. Let's see what happened if we iterate and we found John, right? So in that case, the current is going to be Mary, right? Let me remove the class out.
So what if you're checking via
John.
the content of your linked list? So I'm checking, is this equal to Mary? What happens if I have multiple entries of the same object? So if I
You
have a
mean
linked
this,
list of
like
numbers,
we
I
have more than one
scan-
Mary?
Yeah, if I have a linked list of numbers, this.
You
object
talk about
is
more than one
object
Mary,
four.
right? 1 second. You talk about the two Marys?
Yeah, so if you have a second Mary, like, and you say contains Mary, you're gonna get 2 answers back for that.
So if we have two Mary, meaning like now we didn't break, right? It's actually going to go through the list and remove all the Mary.
Yeah, but if I only wanted to
Because
remove
can
one
find
Mary-
in and again, right? Because we didn't break it out.
So, like, if I only want to either remove one Mary, I want to remove a certain Mary. Say I'm going through my linked list and I add Mary for a second time. I want to take up the second one without moving the first one. Can you remove by position?
So how do you know it's the second one? You say it's identical object, but the second Mary.
Yeah.
then you have to rewrite your code to support that. Like now, our current code cannot.
Currently, the code you're writing supports the idea that you do not have any duplicate entries.
One, or if it duplicate, it's going to remove all the marries,
Okay.
all the duplicates. That's a good question, because that's why it's come to how to implement the stack, queue, order list. It's pretty much just rewrite your code here to support that type of data structure. Graph, binary search tree. That's why I said don't use collections, like don't use the library API. If you write your own, then you can customize your own.
I mean, if you use collections, you just need to, like this, understand what the collection is doing, what the library is doing. You have to understand the methods and how the library implements those methods. I can't just use the library's remove function without understanding how it removes an item.
Correct.
Is it changing the pointer? Is it removing the item and garbage collecting it?
Right.
Etc.
That's the point why I asked you to do it on your assignment too for the project, right?
Yeah.
Then you learn. Alright, so now we come back to remove John. Let's see if would this one work. The between one will work with the tail. So we're gonna find has next. So has next means it's gonna reach to the end at that point. If we review it has next again. Current.get next not equals to no. Right. So meaning your current actually pointing to John. So let's draw that out. So this is gonna be our current. We agree, right? Okay. So now we gonna look at our code again. We said get current. Pretty much your previous is John, correct? Because our current is John, we put previous to John. And then we do dot next dot equals. Now, when we move dot next, this guy should return what?
No.
Interesting. If it's no, you should get no pointer exception at that point. Because no should not be able to get element, right? We test this code. Let's read one more time. Current equals to current.get next. So when we did the iterator, we don't have the problem with no part exception, right? The toString. We said has next and keep appending because these guys will capture first before we call next. Is that true? Right. Then that's why we never get no part exception. But let's come back to remove. So this is going to do the same, right? When it's reached to John, when it reached to John, what happened? Has next is going to be null.
So it's going to be false. So it stops before that?
It should stop before it reached John, right? Because, yeah, it's going to stop the one before John. Right, because next always move to the next one, like the one loop before, right? You guys see that, right? One loop before is going to move to John. Let's remove again. I mean, I try to look at toString. Like, when you do next, you actually do one loop before, because we do head already here. That's why it never do no party exception. See that? Because when it's get to John, it's never do the loop anymore. Okay? So now, when we come back to this, it's going to stop before it reaches to John. Then this one will not work. It never reached to John and remove John.
Do we just make an if statement for just the tail then? If tail
But it's still check for John, right? Like I'm thinking about when it reached the loop before. It's gonna be previous. Like I'm talking about, it's actually going to find John, right, when it get to Mary. Correct? Just like what it's going to find Mary before it get to, it's going to find Mary when it get to David. It's actually going to find John when it get to Mary. Right, so let's see if it's going to work now. So your get current is now it's going to be Mary. And then you said if Mary.next equals to John. There you go. We get John equals to John, right? Then it's going to say what? Previous, which is our previous is when it's execute that line is move this guy here. And it's create a previous pointing here, right? I just slow down a little bit from that line. Correct this line. Dot next move current there and has previous, right? And it said previous is set next to the current. That get next, it works because it's moved it to null, because current get next point to null. So it's technically it works because it's just remove this guy by pointing this to null.
Well, we need to move the tail now, right?
When it's point to null, technically it's just remove that. But you're right, we still have to move tail, which this one never take care of removing tail. Meaning we have to check if this is if previous dot get next or iterate dot get current is a tail, right? So we just check again if this is equals to, how do you know this is a tail? Dot get current dot get next equals to null. That's the tail. Right? So this is check for tail, right? So because where it's null is tail. Then you have to move the tail to the previous, right? Tail equals to previous, right? To finish this image, that's what we did. We're just going to move the tail back. That makes sense? Now we get a new list without John. But that's one thing to consider. Let's say I remove Mary again. It's going to go to the same principle. Your previous and tail is going to move to the head, correct? You agree with me? If I remove Mary, go through the code that we wrote, it's going to look like this, correct? And if I remove David, that means I remove again. What happens? If our code supporting that. So that means we remove the head. Head equal to head.get element equals to David, right? Head equals to head.get next. That means we point null to it. But we never point tail and previous to null. Okay, so we did that. It's not going to do this because it's null, right? But we still fail to point tail to null. That means we have to check again. If it's head and if what head equals to tail, right? Can we check like that? It's going to do the references. We talk about can we do 2 equal sign or dot equals. We want to check the address, so 2 equal sign should be fine, right? Because dot equals will not check the same address, just check the contents. Then, meaning that this is the only element, so we have to set tail to null. How about previous? Like I said, if you use previous, you share them, you also have to set previous to null too. That's why, now if you keep sharing your previous among other methods, it's not a bad idea that when you start to call this method, you want to set your previous to null. Okay, but in this case, it's going to set it anyway. Right here, it should be fine because it always set previous. And then we have to do, after we could remove, we have to set success, right? All right. Any questions? So this is just check if the last element to remove, right? Let's test then. So we're gonna test remove. We're gonna add first and then remove. So if I try to remove David, so I test to remove the head, right? And then I want to print out and check to see the list again, which is called a list. And yeah, let's do that first. I mean, you technically can just write the assert, right, to compare the list. So David's gone, right? Like if you want to write the assert, then just do assert equals and expected pretty much just the output right there. That's the expected, right? Instead of contains, we just use David and remove. Let's see. Oh, because it already removed, right? I removed it once here. It's still like we expected, no part exception. Because I remove once, I remove again, no more debit. Make sense? So if I do this, okay, let's see what happened.
So remove is a boolean.
Right, it's returned true. Then I have to use boolean to check because that's I didn't return what is remained, right? So that's how you write. Yeah, when you check, you just need to check by the boolean. If it's true, that means we're able to remove debit. Correct. Okay. Now we're going to try to remove something in between then, which is Mary. And if this is true, that means we success to remove, which is true, and as we see it's being removed. Now let's retest something at the end, which technically you could just create all the test method for all of those, right? And now we want to remove, let's try to remove the last one. We want to test the scenarios. When you write a test, you have to write a test for all the scenarios. Make sense? And then you can write a test only once. Okay. So this lab code is not right. Looks like couldn't find John. So let's print out what we have before. Before we still have John. Now I try to remove John, meaning that our code for that part may not be correct, right? So it said the contains is a problem. The contents may not be correct then. So we never test contains in the term of only one element. Let me go back and test contains by, if I just have only one, it should be able to find debit. If it's not, then I think the problem is the contains, right? This should be false, this should be true, right? But I feel like it's going to fail the test. It's true. It's found debit. So that means contains work, huh? So in that case, let me try to, now when I add, I only add debit, right? So I want to remove just debit. This should be false, right? But let's just comment it out. Let's print before and print after. Okay, before we have debit. Add is actually print from this guy, right? So that's why we see it twice. They don't need to print before. But there's an error when we try to remove. So something not right. Has next. That's a problem maybe. So it said from this live code, oh, I see. Let's try that. It works. See that? The remove itself works. But when I try to print out, my toString is not working. Why? Because it's nothing to print. The error is actually coming from toString, not remove. Because our toString never taken care of when the list is empty. How would you print out? So let's create an iterator, the iterator, and then if heads not equals to null, it's actually, it never checked that. It should check if the list is empty. It never checked that. That's why we call this, that's why it's created error. Because has next, we don't even have the current is actually null. Try to get next, that's why that's a problem. No part exception. So that's why it's better to create your own exceptions also instead of use a null part exception. Then you know what is the errors. In this case, like we were throwing when we remove, we should create our own exception, like empty link contains is right, not empty. What the object is not there. Not found exception, and then we just going to create our not found exception. It's It's asked for where you want to create. It should be extend exception, and then you just create a constructor from the exception, and then another constructor that take the string msg message and then call super. That's pretty much it. Then you can just do new. Then you want to add exception to there. I should update ilist to have that by itself. See that? And then you can pass a message like the list does not contain, and then you can just say that object, right? Okay, so like when I try to remove the object that's not on the list, then it's going to throw the right message instead always no part exception. Maybe confusing, right, with the other exception on. This is still throwing the no part exception. So it come from contains now. Is if it is empty, this should be return the exception too, right? That exception should be in there too. Because we were talking about it's empty now, right? Okay, let's run again. The error is coming from when we remove, we try to remove again. We should expect to be false, right? Now the error is coming from this line when we remove the second time. If not contains. So it's coming from this line. Yeah, because head.get element is the problem, right? Head is no, that's why no part exception. So why is it even get to this when I actually say it's empty? So is empty is a problem then. That means is empty doesn't work. Let's see how do we implement is empty again. Oh, that's a problem. That means we never reset the tail somewhere or right. Hey, how do you know it's empty? So we were okay. Let's rely on. Yeah, when we remove, we may forget to look at the tail, right? Because it looks like tail is not null. That's why. So let's look back to we remove debit. Go back to remove again. The last one we try to put tail equals to null already, right? Is it really give my tail equals to null? If head equals to tail. Oh, is the head is going to be equals to tail at that point? No. So this is not good one, right?
Yeah, because head is.
Because at that point it's never. That's why we said tail equals to null. So that's why it doesn't work, the last element. So our remove doesn't work. So
Put that before head equals head dot get next.
how do we know this is the last element? We have to fix this code.
When the size is equal to 1.
Yeah, you like because I happen to do get next, that's why, right? You like he said, should we put it before? Because we changed that already, right? Yeah, I think that should work, right? Because now head equals to tail, the last one, right? You see, this could be on your test. You try to tell me a review for the test. I'm telling you, like, if I ask you to implement remove, and it's actually it's multiple choice. If it is, I can just technically put like this, and you may just pick that choice as the answer to implement. A, that one. B, none of the above, and then you just put A because you thought that is correct. I'm telling you that's pretty much a test. Like some of them are just like moving it around like that. Like A, B, C, D, I keep moving the code around. And then I have the last choice that none of the above.
So we recorded this today, right?
Yes, we are. But I'm telling you, this is going to be the test. Like I leave remove method empty like that. And I want you to implement for me the blue part. And if it's multiple choice, I give you the code, but the code can be just like that. Exactly look the same, but only this come before this. You have to pretty much test the code and see which one will work.
So how many questions you probably gonna get about those? Like
A lot of questions
Allowed to use
What?
our
like that. Because you have to do remove, you have to do add, you have to do contain, just pretty much all the methods.
okay.
You have to talk about efficiency of each method. Like that, you have to say how much efficiency of remove. We talk about big O, right? You should know how to implement, you should know how to evaluate the big O.
Are there a lot of questions on the harder sorting methods, like heap and
Yeah, we have those
bucket
too.
and radix? Can we make those questions a little bit easier because they're very difficult to just like memorize. Like the basic concept I understand, but to implement it, it's very hard.
Yeah, to implement is not easy. All right, let's test again. Now, you see, when you do test, unit test is so useful. You see that? You don't have to rewrite over and over again, right? You can just switch back and forth and then run again. When it fail again, have to fix it. What happens, right? All right, it's good. This is a good sign now. This is our own exception, right? But it should be green. It's so exception that what we want, right? Doesn't contain that, correct? Which is good. I make it to though. That's why it's red, because I make it though, I think. But if I want to test, I could just say return false, right? Because it's stored, that's why it's right? No exception at that point. Like if I want to make it green, so technically I don't use that, right? I just return the contain. If I want to return false, right? So let me just commenting this. And the same thing here. I just make it return the success. Now let's test again. That's for the unit test purpose, right? There you go. All green. So we technically done with the remove because we test and it works, right? And add. So you could just go back and think about how we're going to add index with linked list. Clear, very easy. Can you guys tell me how to do that? That's it, right? We just set everything to null. Technically, let's call the constructor again, linked list. So, because you want to clear, everything is going to be null. So that should be on the test, right? Maybe you shouldn't then, because you're quiet. Okay.
No, that's fine. That one's good. I like that one.
Get index of table is empty. Now the rest pretty much just implementing index, huh? On linked list. We did size already. Remove the index. Set that index. We finish iterator. Right. Pretty much the last one is just how do you make the index for linked list. All right, so now think about that part, and I want you to also this implementation we always add at the end, correct? And when we remove, we could remove the top between. When we remove, we just find and remove, right? So if we always add at the end, what type of data structure is that? NQ, Q, right? We were talking about stack also, right, last time. So it's just looking at how you want to use a stack. Maybe you want to add the beginning and keep pushing, right? So you have to re-implement your add for stack. NQ, we add the A, is fine. Now to remove, it should be easy if it's DQ. We always remove the head. And you already know how to remove the head in the code. You just don't care about the elements. You just keep removing. You don't have to find contains anymore, right? You just keep removing the head. Make sense? Until there's no more to remove, it's empty. That's it. Only worry is just it's empty. So technically, you should be able to implement your NQ and DQ for Q. Correct? And now how about list? This is a list. It's an order list. I just implement the list. We add at the end and we can find remove things from the list and update the list. This is called an order list. Okay. So next class we're going to look at maybe how to implement with index in linked list, right? And also priority queues. We talk about stack, list already, and queues I just mentioned. That's how you do it. It's pretty much very simple and easy. Now we're gonna look at how to add the index for linked list.
So what is going to be the homework for the next class?
It should be this chapter, right? And next chapter, right? 25.
Binary trees?
Yes.
So you can look up binary search.
So this week should be 24, right?
Yes, we should finish 24 by Sunday, right?
Yeah, I mean you should be able to do that already.
Well, we just went over it. Now have a
Yeah.
grasp.
Only the index and priority queue. And now, yeah, I don't want to rush on this because it's very important to understand for the test. And this concept is important. Your homework now, you can start to do 25 for next week. Like this week, it's 24, right? It's technically it should be 25, right, this week? Is that right?
Technically, yes.
But it isn't, so it's okay.
Then you should do assignment 2, right, on your... Oh, I didn't check that yet. It's been 16. It's past 16, right? You guys finished assignment 2 for project?
Yes.
I'm gonna check real quick.
Yes. All right.